Within National Grid we've got a major investment programme to replace our ageing assets. To deliver that capital programme we set up 6 electricity alliances. There are 2 electricity alliances covering overhead lines and cables, and Balfour Beatty are working in the East Alliance covering all the way from the top of England right down to the southeast corner.
The original project was to replace some existing 400 kV cables that run through some Victorian railway tunnels.
These tunnels are past their asset life, and the integrity of these tunnels cannot be guaranteed. So we purchased the old railway tunnel, and the challenge for Balfour Beatty was to site the replacement cables in a brand new tunnel.
Traditionally we would have installed these cables using an old winch and bond method. It's very slow, very labour intensive.
So we asked Balfour Beatty up front to come up with a new innovative way of installing cables that increased safety and reduced the amount of manual handling.
We first identified the company after doing a search on the internet for machines that could install cable inside of tunnels. We looked into various other projects that have been completed in the world and found one specifically interesting in Sydney in Australia.
In 2000, a company called Tescorp was commissioned to supply a machine which has now become a machine called the HLSM.
The innovative solution of this machine is to reduce the amount of men that's needed to install the cable. The conventional techniques had 30 or 40 men installing the cable on the side wall of a tunnel. This machine uses less than 5.
We were given really good staff from Balfour Beatty that gave us some excellent specifications for the tunnel and what we needed to do. So we just took the information that they gave us and converted that into a machine that was very similar to the last HLSM machines. It just simply had to put the cable a little bit higher than traditionally, and it was a little bit bigger cable.
The Woodhead project was specifically different from anything else that Tescorp had been involved with, primarily because the tunnel was 7.6 metres diameter.
The biggest challenge is always integrating into the safety and the programs of the country that you're travelling to. We're extremely fortunate to have an operations team in Woodhead that was sensational, and they effectively did most of the work, and we simply needed to guide the guys.
Once the machine had been completed, before it came over to the UK, we asked if it could have some factory acceptance tests. I went over to the factory and spent a week there just to understand the various features and functionality of the machine. This included sending 2 operators to work on the machine both in the daytime and at night time, specifically so they could understand how the machine worked in the dark.
I was out there 10 days of twisting, pulling, hanging the cable up, taking the cable off, going backwards and forwards with the train, seeing how we could make the train more efficient for our way of cabling.
There is an element of textbook training that they have to understand because the machine is quite a sophisticated piece of equipment. It's far more complicated than just a car, although it does obviously run on rails, so it's similar in one way to a train.
Because the machine is so large, it's difficult to transport it in a complete unit. And it was disassembled in Australia and put into 3 containers.
It was like a big Meccano set when it first come. It took up to like 2 weeks to assemble. We'd never got involved in that bit because when we went to Australia, it was already built, it was already on tracks. It was a brand new experience again.
The operation of the machine is quite simple, and originally when we were working in Auckland in 2000, they were using a crew of about 45 people, and we were able to bring that crew down to 10, with 3 of those guys being operators on the machine. One drives the machine to make sure they don't run into anything. A second one operates the component of the machine that puts the set into the cable, and there's a 3rd team member.
It also has a camera system so they can monitor the position of the cable against the cleats and the uprights. Once the machine starts to move and install the cable, it moves at a fixed speed. And once the operators learn that they can drive the machine at that fixed speed, it's virtually an automated process that puts the cable directly into the cleats, sags it, stops for a small period of time to allow the cleat top to be clamped into position, and then the machine starts again until the cable's completed.
What we do normally is we'd pull the cable, then it'd be manpower then to physically lift the cable up into the troughs. With this machine it's automatically done, it's one hit. You pull the cable in, you lift the cable up, and off you go.
Now we can put cable in and consistently sag the cable within 5mm of every sag. So it's sped up the process by being far more consistent.
It's a great machine and it's just a lot safer. You don't need to use as much men or anything, so it's ideal for the job.
Safety was the biggest driver that we had. We wanted to reduce manual handling, we wanted to reduce the number of people that were exposed to risk. By automating the process, we were able to get the amount of men down to a minimum, take out all of the manual handling risk, and that provided a much safer, more efficient solution both for Balfour Beatty and for National Grid.
We're aiming at zero harm, and if we can reduce that risk by innovation, by using new techniques, then that gives us a significant benefit. Delivering value to our clients, again, significant reduction in programme and cost, but equally it gives us the opportunity to sell what we can do across the world to other parties.
The benefit for Balfour Beatty was within the parent group, they had the full range of capability to deliver this project. It involved complex civil engineering, complex tunnelling because we had to sink a shaft. There was obviously all of the complexity around the electrical installation. So within the single group, we were able to get all of the knowledge in one place.
This machine fits exactly in with our objectives and our goals. We've demonstrated that this machine is safer. It's clearly better over the old technology. It is demonstrably leaner in terms of the number of people and the time, and equally it's faster and far more economic for everybody.
Having the multifunction trailer fitted on the back demonstrated that we can install a cable in any type of project where it's inside a tunnel.
The cable team have improved so much. Everybody knows what they've got to do. It's like a well-oiled machine. Everybody knows what and when and how they've got to do this safely and appropriately.
We've developed the machine on the Woodhead project. We're going to move that across now to another National Grid scheme in London, which is 7 to 10 years work of installation of 400 kV cables, and we are further developing it internationally for a scheme in New Zealand where we're going to use the same technology to install some cables in Auckland.
Part of the driver for asking Balfour Beatty to come up with this innovative solution is we're going to be doing an awful lot more work in tunnels, in confined spaces. We believe that this solution is part of the future. It is fundamentally re-engineered the way we install cables, and this going forward should become the traditional method.